In this demo, we'll be using interfaces to dynamically extend the capabilities of our CalcEngine app. As you recall, earlier in the course, we had the ability to our CalcEngine app where we could type in things like this, where we say add 1.0, 2.0, and the CalcEngine app would then do the calculation and then write back the result in a more traditional format, right? 1.0 plus 2.0 equals 3.0. What we want to do now is make this more dynamic. Currently, the way the app is written is that the code that actually does all the work to take things apart and produce the results is tied to a very particular class. What we want to do now is make that more abstract. Make the core work behave in terms of an interface and then have specific calculation abilities implement that interface so we can easily plug in new abilities into our CalcEngine app. Here we are in our CalcEngine app, and we're picking up our code where we left off at the end of the last module. But what I've done though is that all the code that was in our main function is now in this function called useCalculateHelper. And I've put a call into that function but commented it out. Then what I've done is I've stripped it down so we have just one statement. You can see the add 25 and 92. And then a simple for loop to walk through that array of statements. So what we want to do now is again take that functionality that we have in CalculateHelper but make it more dynamic by using interfaces. Now if we look at our CalculateHelper class, if we go inside of here, basically when we process a statement we do a few fundamental things. First of all, we split it apart based on a particular character, which is the space character. And then once we split it apart, we have to identify the command we want to execute. If I scroll down here, currently the list of commands we support is hard-coded. Right? Add, subtract, multiply, and divide. So we've got to work through that list. And then what we want to do is do the operation, but our operation is done in terms of a base class, calculate base, and then we produce output. Right? And the output relies on having a symbol for each operation. If I go up top here, you see that each symbol is hard-coded, right? A plus sign, a minus sign, an asterisk, and a slash for divide. What we want to do now is take these ideas and implement them more generically using an interface. So let's go ahead and create an interface now that represents the parts of doing this work. So I'm going to go out here, I'm going to go ahead and add an interface. So I add an interface in IntelliJ very similar to a class. Just do a right click and new. And the way it's on IntelliJ is that it's still the new class dialog, but we changed this from class to say interface. But we'll see that we could actually just type it in very easily. And we'll call our interface math processing. So go ahead and create that. And you can see the declaration is very simple. It looks very much like a class. It just says interface instead of class. So we want the interface to represent the parts of what we need to do. So let's go ahead and add those in there. So first thing we'll do is we'll add a constant called separator that has a value of space. That's the character we use to split statements apart. And then we want to model what we need to know for anything that implements operations that do these calculations. Well, one thing we need is a keyword. So let's add a method called getKeyword. So that would give back a keyword that a particular implementation knows how to handle. So for example, it might be something like add, if there's an implementation that knows how to do adding. The next thing we need to know from any implementation is what symbol it wants to use in the output. So I have another method called getSymbol that's of type character. Or for something that did addition, that would be the plus sign. And the last thing we need to do is actually perform the operation. So let's create a method called doCalculation that returns a double. And it accepts two values, a left val and a right val that are both doubles. So that's our entire interface. Again, there's no implementations, it's just a contract. Right? Classes that implement this will conform to the math processing contract, which means they have to identify the keyword they know how to work on, return back a symbol that will be used to produce the output, and then do the calculation that goes with that keyword. So what we can do is go ahead and use our existing adder class to implement this interface. So I'm going to go over here to my adder class. I'm going to go ahead and have it here, implement math processing. And of course, we have to go ahead and provide the methods for that. So I'm going to let the IDE do that for me by just saying implement methods. I want to implement all the methods with that interface. So we'll say OK. And so that now provides those methods. Right? So we just have to do the work associated with each method. Well, my adder, the keyword that it handles is add. So I have it return back the word add. The symbol that it uses is plus sign. And then we have to do the work. Right, where our adder is written in terms of this calculate base class, so we'll do the addition using the calculate base class way of doing that. Right, so the first thing we'll do is we'll set our left value, then we'll set our right value, then we'll call our calculate method, and then finally we're going to return back the result. Scroll here so we can see everything. So you can see now that's everything adder has to do to conform to this interface. Now just one thing to note, if I scroll up here, Adder extends calculate base. So we could have had calculate base implement the math processing interface if we wanted all 4 classes that inherit from it to implement the interface. We basically just had calculate base, say it implements math processing, make all the interface methods abstract, and the derived classes would then implement them themselves. But we're going to focus in here now just on having adder do it. So this gives us now a class that implements that interface. In the next clip, let's see what code we need to write to now use this interface.